We are now solving by using the quadratic formula. If I gave you an equation with generic coefficients, so ax squared plus bx plus c equals 0, and I ask you to solve it by completing the square, well, we would first of all get rid of that coefficient, wouldn't we? So, well, actually, since I started it, I'll go ahead and take c to this side first. Everything by a. And you don't have to write this down, just watch it. So I would have b over a equals negative c over a. Now, if I need to pick the magic number that will complete the square, I'm going to take half of b over a, which is b over 2a, isn't it? And then I'm going to square that. So that would be b squared and 4a squared on the bottom. And I need to add 4a squared on the bottom. Now to both sides of my equation. We just did this, didn't we? And we now know that this will factor into a perfect square, and it will be the number before we squared it. So it will be b over 2a, won't it? On the right, I have to get a common denominator, so I'm going to times this by 4a and this, oh, I wanted my red, this by 4a and this by 4a. And you might just put that in a box. You remember you're multiplying by it. But now I have negative 4ac, right? Negative 4ac plus b squared. And that's all over that common denominator of 4a squared. Alright, now I've got to go ahead and get x alone. So I'm going to square root both sides. So I'm going to square root this side, I'm going to square root this side, and don't forget that plus or minus. So on the left, the square and the square root cancel. So I just have what's inside. And on the right, let's see if we can simplify anything. I have plus or minus, and the top, I'll leave it the same, but I'm going to write b squared minus 4ac. So I'm just going to flip-flop those. So I have b squared minus 4ac. But look, on the bottom, I can take the square root of 4. So then, if I get x alone, I'm just going to subtract negative b over 2a. So I'm going to have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So since those have a common denominator, I can write that like this. Now, everything you just watched comes down to this equation right here. That is called the quadratic formula. And that equation, that quadratic formula, without factoring. So it might not be factorable, but x equals. X equals this coefficient, use a, b, and c as those coefficients in those spots. So this is a memorize. You have to memorize it. You must know it before your next test and before the final. This is the quadratic formula, and it will come in handy from now till forever, as long as you're in math. So let's try a problem. So for example, your homework might say solve, and it could look something like this. And you can see that you could try to complete the square, but you'd have to divide everything by 2, and then you'd have a fraction, and just plug it into our quadratic formula. So our quadratic formula says x equals negative, doesn't it, b. And look, our a is 2, our b is 9, and our c is 10. So a is whatever's by x squared, b is whatever's by x, and c is the constant. So plugging it into our formula, I have negative b, which is 9, plus or minus the b squared, which is 81, subtract 4, that's part of your formula, times a, which is 2, times c, which is 10, all over 2, times a, which is 2. So it's just a memorize and a plug. You just plug it in, but now you have to just simplify, and that's not hard, so we'll just simplify. So look what I have. I have 81 minus 4 times 2 is 8, times 10 is 80, all over 4. So negative 9 plus or minus the square root of 1 all over 4. So I get negative 9 plus or minus, we know the square root of 1 is 1. And guess, you can take the square root, if this number inside, that means this was initially factorable. So we could have just factored it. But if we couldn't figure out how, or we didn't want to factor it, you can always go to the quadratic formula. But notice we're still not done, because this is two answers. This is both negative 9 plus 1 over 4, and it is negative 9 minus 1 over 4, because it says plus or minus. So one problem's the plus, one problem's the minus. So going further, I would have negative 8 over 4, which is negative 2. And here I would have negative 10 over 4, which reduces to negative 5 halves. So those are my two answers. My two answers are negative 2 and negative 5 halves. That is my solution. Let's just do another one to make sure you have that down before you're on your own. So let's 6x squared minus 1/2 x minus 1 equals 0. And this is the thing. We don't want to be plugging fractions in our quadratic formula. We don't want to have to plug fractions in. And in fact, let's just take a second and write that quadratic formula down. So we need b plus or minus the square root of b squared 4ac all over 2a. And you know what? I've had students that memorize that to songs. I think it was Jack in the Box. They would go negative b plus or minus the square root of b squared. Anyway, I can't exactly do it, but it was all over 2a. So memorize it in a way that's easier for you, but absolutely get that down. Alright, but here's the thing. We don't want to plug a, b, and c in as those yucky fractions. So we're going to do what we've done the whole semester. When you have an equal sign and you have a fraction, you can get rid of it. You just pick the least common denominator and multiply every single term by the least common denominator. Don't forget to do every term on both sides of the equal sign. So here the 6 cancels, gone. Here the 2 reduces and I have 3x. Here I have 6. And what is 0 times 6? Still 0. Now, this is the first time we've seen a number here. If this isn't the perfect number that factors into a perfect square, oh wait, we're using quadratic formula, I'm sorry. Here we go. X equals negative b. Our b is negative, isn't it? So I have negative 3 plus or minus the square root of b squared minus 4c. And again, that has a negative in front of it, so it's negative 6. All over 2a. So just plug it into your formula. A is 1, b is negative 3, c is negative 6. And then simplifying, so we get 3 plus or minus 9 plus 24 all over 2. 3 plus or minus, what is that, 33? All over 2. And if that will simplify, you should simplify. And note that if you can reduce, you should reduce. But to reduce, it has to come out of all 3 terms outside of the radical. So don't reduce something in the radical with something out of the radical. And you have to be able to take it out of all 3 to reduce it. So just be careful, and this is a great resource. You can now solve by completing the square, you can solve by factoring, and you can solve by the quadratic formula. Good luck, you guys.